Hey Bio Team. So as we mentioned in class, if you had to bet on whether a gallon of water would evaporate from inside of a bucket faster or faster after being spilled out onto the ground into a puddle, the smart money would be on the puddle. And the reason behind this is that water can only evaporate from the surface of the water. And so while our puddle has the same volume as our bucket of water, it has a lot more surface area from which the water can evaporate. And so we say the puddle has a higher surface area to volume ratio. So this is the reason why cells are so small. Their small size gives them a higher surface area to volume ratio, which lets them absorb and release materials faster. So for an example of this, let's say that we had a giant cell compared to 4 smaller cells that add up to the same amount of volume as the big cell. And let's say that these cells are thirsty and they want to fill themselves up entirely with water. Well, the only place that these cells can absorb water is through their surfaces. And so if we look at this big cell, we can see that it has 8 units of surface area available to absorb its 4 milliliters of volume. So we'd say that its surface area to volume ratio is 8 to 4, which would reduce to 2 to 1. Whereas these smaller cells, if we look at their surface area, we would see that the smaller cells have a surface area of 16 available surface units, available to absorb the same 4 milliliters of water. And so we'd say its surface area to volume ratio is 16 to 4, which reduces to 4 to 1. And so these smaller cells would have a higher surface area to volume ratio. They'd have more surface available to absorb the water. So in this class, you'll be expected to calculate the surface area to volume ratio for 2 shapes, for spheres and for rectangular prisms. And so to calculate the surface area and volume of a sphere is going to be relatively straightforward because the AP Bio test will actually give you the formulas for calculating the area of a sphere and for calculating the volume of a sphere. So if we wanted to do this for this sphere right here, we would see that the area is equal to 4 pi times the radius squared. And so if we just plugged that in this case our radius is 2.2 centimeters, we would find that the surface area of this sphere is 60.8. And to calculate the volume of this sphere, we are given that the formula for a volume of a sphere is 4/3 pi times the radius cubed. And so if we were to plug in our radius, 2.2 centimeters, into that formula, we'd find that the volume is 44.7 centimeters cubed this time, rather than squared. So the units are slightly different. One is talking about flat surfaces, and one is talking about 3-dimensional space. Anyway, the surface area to volume ratio of this sphere then would be 60.8, the surface area, compared to 44.7, the volume, which would reduce to 1.4 centimeters squared for every 1 centimeter cubed. Now, if we want to calculate the surface area to volume ratio for the rectangular prism, we're also given the formulas for surface area and volume. Now, this formula looks a little bit complicated. With this sigma Greek letter here. But to calculate the surface area, all this simply means is that you need to add up the surface areas, take the sum, that's what that symbol means, of each of the 6 surfaces on the prism. So let's start by taking the surface area of the bottom of this rectangular prism. To find the surface area of the bottom, you just take 3 times 6, and you'd find that the surface area of the bottom would be 18 centimeters squared. 18 square centimeters. Of course, the top then of the rectangular column would have the exact same surface area. 3 times 6 would be 18 centimeters squared. And then we could take the surface area of the side here. This would be 3 centimeters times 4 centimeters, or 12 centimeters square, which would be the same as the opposite side, 3 times 4. And then we'd take the surface area of the front of the cube, which would be 4 centimeters times 6 centimeters. And that would be the same as the surface area of the back of the cube, which would be 4 centimeters times 6 centimeters. And you add all of those up together and you'd end up with 108 square centimeters. Meanwhile, finding the volume of a rectangular prism is significantly easier. The volume of a rectangular prism is the length times the width times the height. And so in this case, 6 times 3 times 4, which would give you 72 centimeters cubed. So the surface area to volume ratio of this rectangular prism would be 108 square centimeters to 72 cubic centimeters, which would reduce to 1.5 square centimeters for every 1 cubic centimeter. And so if we were comparing the surface area to volume ratio of the sphere with the rectangular prism, we'd find that the prism has a slightly more efficient surface area to volume ratio. It has a little bit more surface area for every cubic centimeter. And so it'd be a little bit more efficient at absorbing and releasing materials. And that's it. At this point, you guys have some practice problems. We'll see you next class.